Okay, lesson 15 is just a continuation of the topic of lines, right? We were talking about lines on lesson 14. So the first couple of pages of this lesson are just to talk about a little bit more about lines. Recall from the previous lesson that you have this formula that gives you the slope of a line, rise over run, right? Subtract the y's, that goes on top, then subtract the x's, that goes on bottom, and just keep the order consistent. Now, suppose you want to find an equation that describes an arbitrary point on a line. So how do you figure out what is the equation of a line? Well, here's how the story goes. Suppose that you have a line, let's say these are my axes, they're a little bit crooked, but okay. Um, Suppose I have a line, and suppose I have a point on that line that I know. Let's say it is x1, y1, and then you want to figure out what is the formula that gives you the coordinates of an arbitrary point on the line. So since it is arbitrary, right, we don't know what it is. Let's call it x, y. So that's an arbitrary point on the line. We are calling the line L. Okay, we know that this line has slope m. The slope equals m. On the one hand, on the other hand, we know what the slope is from the formula, right? So we subtract the y's, so y minus y1 over, now subtract the x's, x minus x1. Now, if you multiply both sides by x minus x1, or another way of thinking about it, imagine that m is m over 1 and cross multiply, right? You're going to get that y minus y1 times 1 doesn't do anything equals m times x minus x1. And that right there is the equation of a line. It is a very important equation that is used a lot in not only college algebra but in calculus as well. We use that in calculus all the time. The entire semester using this formula. So you really need to memorize this formula if you have to take calculus. Right? It is a very useful formula. So this formula is going to give you the equation of a line if you know the slope m and you know another point on the line, x1, y1. And this formula is called the point slope form of the equation for the line. The point slope form, because all you need to figure it out is a point x1, y1, and the slope m, right? If you know a point x1, y1, and the slope, all you have to do is plug it in there. And that's the equation. You got it. That's the equation in the point slope form. Now, there's another form. There's actually various forms. This is not the only one for the equation of a line. Another form that is pretty popular is the slope-intercept form. And that is just a special case. So this one, it is a special case in which the point, instead of being x1, y1, the known point is 0b. So if you have this formula, right, and you happen to know that x1, y1 equals 0b, then plugging that in there, you're going to get that y1 is b. So you would get y minus b equals m, and then the x1 is 0, x minus 0, which simplifying gives you y minus b equals mx, because x minus 0 is just x. And then moving the b to the other side, you get, right, move it to the other side, it becomes positive. You get y equals mx plus b. And that is the other form of the equation of a line that is pretty popular. And that's usually the formula that we will use when we're reporting, right? Like if I ask you what is the equation of a line, normally what you do is you use this formula and then move the y1 to the other side and simplify this by distributing and report your answer like this, right? Because this is usually more useful, I guess, because you still have a point, right? The b is a y-intercept, and you have the slope, and it's easier to read and easier to deal with, and so on. So this is usually the preferred form. Now, using these two formulas though is pretty easy. So here's the first example. It says find the equation of the line that satisfies the given conditions. There's three examples in this one. In each case, express the answer in slope-intercept form. So in each case, we're gonna give the final answer like this: y equals mx plus b. All right. So here's the first one. Find the equation of a line that passes through the point 0, -2, and has slope 5. This is the point, right? So this is my x1, y1, and the slope, they're telling me it's 5. So this is my m equals 5. All right, so all I have to do is plug in here and then put it like this. Okay, so let's do that then. All right, this is going to be, I'm going to plug it in. Y minus y1, y1 is -2. So you get y minus -2 equals m. Oops, sorry, that was my cell phone. That went off. Oops. Okay, the slope is 5, and this is x minus x1. Now x1 is 0. Okay, and then you simplify this, so we can give the answer in this form. So this is going to give you y plus 2 equals, well, x minus 0 is x, so this is 5x. And then moving the 2 to the other side, you're going to get y equals 5x minus 2. Okay, and that's the answer for that one. Now we could have done this even quicker still, because if we had not noticed that this is actually happens to be the y-intercept, meaning the b is -2, then all we had to do was say here b is -2, m is 5, and done, right? So that would have been even quicker. But if you didn't notice that, then this formula always works, right? So that's the one I'm usually going to be using, this one. All right, so here's another one. Suppose that we want to find the equation of the line that passes through the points -2, -1, and 3, 7. Okay. Note that this equation needs that you have one point. Well, we have a point. We have 2 points, actually. We only need one. We're going to use the easier one of the two. And we need the slope. Okay, since we don't have the slope, that's going to be the first thing we need to do. We need to find the slope first of all. So slope is going to be, okay, let's use the formula, rise of a run, 7 minus -1, careful with all those signs, 7 minus -1 over 3 minus -2. So this is 7 plus 1 over 3 plus 2, which is 8 over 5. So the slope is 8 over 5. And now we use any of the 2 points. I usually like using the one that has the least number of negative signs, because negative signs are usually, trip you up. So I'm going to use the 0.37 instead of -2, -1. Okay, so now you just plug in m equals 8/5, and then x1 equals 3, and y1 equals 7. So in this formula, right? So it's going to be y minus 7 equals m, which is 8/5, x minus x1, which is 3. Okay, so that's the equation. It's not in the slope-intercept form, so let's put it in slope-intercept form. This is going to require 2 steps. So this is going to be y minus 7 equals distribute. So this is 8/5 x, 8/5 x. Zoom in a little bit there. 8/5 x minus 24/5. Minus 24/5. Now add 7, move the 7 to the other side and simplify. So we're going to have y equals 8/5 x. And now let's add, I'm going to do it on a separate piece of paper. Let's going to figure out what -27 fifths plus 7 is. You can use a calculator for this. I'm just going to do it by hand. So this is going to be -24/5. Then this is like 7/1, multiply by 5, bottom and top. So this is 5/35, which is, that's 11. -24 plus 35 is 11. Okay, 11/5. Okay, so that means this thing over here, when you move the 7, right, and you combine with that, you get 11/5. And that's the answer for problem B. And now we have one more. It says find the equation of a line whose x-intercept is -3, 0, and y-intercept is 0, 4. Okay, this problem can be done exactly like the one we just did, right? You find the m first, and then use either of the points. However, I also told you when we solved this one that if you happen to notice that one of the points that you have is the y-intercept, then is a lot quicker. And this point right here is the y-intercept. So I noticed that. So what that means immediately right away is that the b is 4. Right? So that noticing that is going to make this problem a lot faster. But if you didn't notice that, you could just do it just the same way we did b. Okay, noticing that b equals 4, all we have to do is find the m, and I'm going to use this formula then. I have the b, I need the m, and then I'm going to put it in here. Okay, so let's find the m. M is going to be negative, what am I saying negative? You subtract to the y, so 4 minus 0, 4 minus 0 over 0 minus -3. And that is 4 over +3. And now we have both the m and the b. So that means, right, plug it in here, y equals mx plus b. We know the m, we know the b. So this is going to be y equals 4/3 x plus 4. And that is the answer. for this one. Okay, example 2 says find the slope of the line 8x minus 4y equals 4. Note the amount of space I left for this. This is a quickie. This is an easy problem. Okay, we know the slope. If we had been given the equation in the form y equals mx plus b, then we know that the slope, which is the m, is what is in front of the x. The slope is what is in front of the x, but that's only true if you have solved for y. If the equation doesn't look like this, if it is not solved for y, then what is in front of the x may or may not be the slope. It is only what is in front of the x if you have solved for y. So that means here, what is in front of the x is 8, may or may not be the slope. I don't know. The only way we can know what is the slope is solving for y and then seeing what is in front of the x. Okay, so we're gonna first, all we have to do then is solve for y. So let's solve for y. Okay, so we're gonna move the 8x to the other side. We're gonna end up with negative 4y equals negative x and positive 4. And now divide by negative 4. Negative 4, everything gets divided by negative 4, right? So you get y equals, and remember that this means that everything on the top, oops, I kind of ruined that. Everything on the top gets divided by negative 4. So negative 8 gets divided by negative 4, and this 4 gets divided by negative 4. So negative 8 divided by negative 4 is positive 2x, right? You have negative 8 divided by negative 2 is positive. Negative 8 divided by negative 4 is positive 2, and you still have the x. And then 4 divided by negative 4 is negative 1. So you can put minus 1 or plus negative 1, same thing. So that is the equation of the line, but solved for y. And now, comparing with this, the slope-intercept form, that means, right, comparing directly, that means the m has to be 2 and the b is negative 1. We're looking for the slope, which is the m. So that means the m equals 2. That's the answer. M equals 2. Okay, so the moral of the story, if you have the equation of a line, you can figure out what the slope is by just looking what is in front of the x after you have solved for y. Solve for y first, then once you have solved for y, what is in front of the x, the coefficient of the x, is the slope. Okay. There's 2 more examples on this page. We already discussed how to graph equations of lines. We did that on lesson 14, if I remember correctly, I think so. So you already know how to graph equations of lines. So if you're good with this, that's fine. But here, the point is I'm going to show you another method that is pretty cool, that is also very convenient and even quicker than just plotting points. It is actually much quicker, more convenient. So the method consists of, let me write this a little bit bigger. The method consists of thinking 2 things. Thinking of the slope, which in this case is negative 2, thinking the slope as a fraction. Think of the slope as a fraction. Right now it's a whole number, it's not a fraction. So you have to think of it as a fraction by writing it as negative 2 over 1. And the reason we want to do that is because if you remember the formula for the slope, it is a fraction, right? It is rise over run. So we need to think of the slope as a fraction so that we can think of rise and run. So in this case, this means the rise is -2 and the run is 1. And we're going to use this information after we start 1 point. We plot 1 point and then we're going to use this. So what is the point we can use? Well, the intercept is 3. So that means automatically I have a point for free. The y-intercept is 3, so 1, 2, 3. So that means the line is going to pass through that point. So we have a point 0, 3. This is a point on the line. Okay, so 1, 2, 3. And then from here, now we're just gonna rise -2 and run +1. Rise, the fact that it's a -2 means you actually go down, right? If the rise is a positive number, you go up. If the rise is a negative number, you go down. So rise, right, is you move vertically up and down. Positive up, negative down. For the run, you move horizontally. Positive to the right, negative run means you move to the left. So starting from this point, we're going to rise -2. That actually means you go down 2. So we would be right here. This is 3, by the way. That's 3. So we'll be right here at 1. And then we have to run 1 over to the right. So 1, 2, down, 1 to the right. So this is another point of the line. And once you have 2 points on the line, you can connect to them. And that's the end of the story. That is the graph of the line. Okay, my line is not that pretty, but so these are the points. The points were 0, 3, and what is this one? This one is 1, 1. Okay, that is it. So using the slope as a fraction, you think of it as a fraction, you can immediately find another point. The first point is always going to be the intercept, which is the b. So start at the intercept and use the slope to get another point, and then you have 2 points and you connect them. Here's another one. In this next one, first we have to find the equation of the line and then we're going to graph it. So there's one more step here. We have to first find the equation of the line, given some information, and then graph it. Okay, find the equation of the line. We have a point. We have a point, so this is our x1, y1. And then, remember, we need a point and a slope. And then we're going to use this formula. We have the point, we need to find the slope. Okay, what is the slope? The slope, they're telling us what is the slope indirectly because they're telling us the line that we're going to graph is parallel to this one. So the fact that it is parallel means that it's going to have the same slope as that one. Now, what is the slope of that one? How do you figure out what is the slope of that one? To find the slope of that one, we do like we did here, right? We solve for y. Once we solve for y, what is in front of the x is the slope. So let's solve this one for y, so we can figure out the slope. So move the 5x to the other side. This is -2y equals -5x plus 4, right? Move the 5x to the right, it becomes -5x plus 4. And now we're going to divide by -2. Remember, everything gets divided by -2. So we're going to have -5 over -2x plus 4 divided by -2. So really simplifying, This is positive 5 half x, and then 4 divided by negative 2 is negative 2. So that is the equation of the line. Oops, that's my bad. That's not right. This is the equation of the line that is parallel to the one we're looking for. So now that we solved for y, that means the m is 5 halves. That's the m. This is our point. And now we can write down the equation. So the equation is going to be y minus y1. y1 is negative 4. Y minus negative 4. M, which is 5 halves. X minus x1, which is 2. Okay, now let's simplify this. This is y plus 4. Distribute this. 5 half x. 5 halves times negative 2. That gives you negative 5 because the 2's cancel. Look, you have 5 halves times negative 2. You can cancel the 2's, you get negative 1. So 5 times negative 1 is negative 5. Negative 5. And now move the 4 to the other side. You're going to get y equals 5 half x. And then when you move the 4 to the other side, it becomes negative. So negative 5 minus 4 is negative 9. And that is the equation of the line that we're looking for, that we're going to work with. Okay, to recapitulate before we graph it, they give us a point and they give us the slope indirectly. They told us the line is parallel to this other line. So if it is parallel to this other line, that means it has the same slope. But what is the slope of this one? To find the slope of this one, you solve for y. Once you solve for y, whatever is in front of the x is the slope. So the slope of this line is 5 halves. The lines are parallel, so they have the same slope. So that means the m is 5 halves. And then you have, use this other point, use the formula, y minus y1 equals m parentheses x minus x1. Plug it in there and get your answer for what is the equation of the line. And lastly, we're going to use that to graph that line really quick. All right. The m is 5 over 2. This is rise over run. It is already in terms of a fraction, so we don't have to do anything, right? If it was a whole number, you put over 1. Think about it that way. But it's already a fraction, so that's good to go. So starting at negative 9, sorry, negative 9 is the intercept. Starting at negative 9, this graph is 10 by 10, so negative 9 is right here. Starting at negative 9, you go up 5, you rise 5, up because it's positive, and then 2 to the right. So this is going to be 1, 2, 3, 4, 5, and 2 over 1 and 2 right here. Let's do that again. 1, 2, 3, 4, 5, 1, 2. Okay, so this point is 0, negative 9. And this point is, okay, this is negative 9, 8, negative 7, 6, 5, 4. That is negative 4, negative 3, negative 2, negative 1, 0. Yeah, negative 4. And then we move 2 to the right. So the coordinates of these points are negative 4, 2. Okay, now let's connect them. And that's our line. Okay. Okay, one last thing before we move on to the next part is that when you're using this trick of drawing the equation of the graph of the equation of a line using this method, like start with a intercept and then use rise over run to find another point real quick and then connect them. If you have a slope that is negative, like this one, right? Remember I told you that if you have a fraction that is negative, you can have the negative sign on the bottom, and it's still the same thing. So negative 2 over 1 is really the same thing as 2 over negative 1. So that means I could also have done rise 2 and move 1 to the left. That also works. It's not going to give you the same point. It's not going to give you the same point, but it's going to give you the same line. Right? So this one, I started at 0, 3. I went 2 down and 1 right. So I ended up here. If I had interpreted the slope as 2 over negative 1 instead, which is the same thing, I would have gotten, let's see what point we would have gotten. You go 2 up, using this interpretation, you go 2 up and 1 to the left. So 1, 2, and 1 to the left. We would have gotten this point on the line. So you see, you get another point on the line. It's not going to be the same one, but then you connect the 2 points, the intercept and this one, and you get exactly the same line. So it really shouldn't matter. You could do it either way. You get the same line. You don't get the same points, but you get the same line. And that's what matters. If we just tasked with graphing the equation of a line, you get the same graph.